Hello guys! At this time I was thinking to make this kind of regular coding video. So in December I was a bit busy, the holidays were coming in, so I didn't have any time to check out the Advent of Code for 2024. So I was planning to check it out now or start checking it out now, and I was thinking that I'll take you guys with me so you can see how I'll succeed or fail miserably. But let's start. So I think you should see my screen now, and I think we can just start by clicking the first. So in this first exercise, Civilization is always present for the big Christmas late launch. Nobody has been seen in months. Last anyone heard was he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. Okay. As each location is checked, they will mark it as their list. In the start, they figure out chief historian must be in the place they look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. I guess that slate went already. Collect stars by solving puzzles. Yes. Even someone decided that the best place was office. When walking into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead of notes and list of historian's significant locations, this seems to be the planning chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Office, the historian locations are listed not by name but unique ID, okay, location ID, to make sure they don't miss anything. Historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There is just one problem. By holding the two lists upside by side, it quickly becomes clear that the lists aren't very similar. Maybe you can help historians reconcile their lists. Okay. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Then the second smallest left number with the second, and so on. Okay. Within each pair, you figure out how far apart the two numbers are. Okay, you'll need to add up all those distances. For example, if you pair left list on the distance apart 4, if you pair up 9 with the 3, the distance apart is 6. Okay, that sounds relatively straightforward. In the example list above, the pairs are distance would be as the follows. Yes, distance between is 2, surely. The second, yes, third smallest. Yep. Yes. To find total distance between add up distances. Okay, yes. Yes. Cool. Okay. So usually I have done these puzzles so that I have like created local files with the language that I have chosen. For this time I was just thinking that I'm more interested in these puzzles than learning something new. So maybe Python would be okay this time. And also this time I wanted to try out to solve these puzzles in the Colab so that I don't have to set up the whole development environment and that stuff, because I might do this from different computers and so on. That kind of gets a bit then annoying. But yeah, let's start the puzzle. So to begin, get your puzzle input. Okay. We might need to do some. I made this simple helper script which I used to parse this input, so we can do it like this. Yes, and then we can just run that. And then what we needed was that we need two arrays. Okay, first left list. Basically what we can do is to we can do this. So let's not shadow cast the variables. I think this should be fine for the left one, and then we can basically copy paste it for the right one as well. And I think this should run well. Let's double check left list. How does it look? Yes, wonderful. So what we can do is, or what we want to do is that we will sort the lists through. This is actually in place, I think, based on the fact that we didn't. Yes. So and then actually we could just do next step here. Then what we need from these two lists, let's actually first make sure that they are in order. Seems okay, good. So we need distances, which could be an array, and for loop we could do it using chip, I think, for left right in zip, left list right right list, then distances dot append, yes, ups left minus right. Yeah, I think we should then be good. Let's check what we have in the no, the distances. Super. So what we could do is just sum them up. And let's see, is this our answer? Is too high. Okay, maybe. Okay. The one total distance between left and add up the distance between all the pairs you found. Yeah, there's almost number in there. Okay. Let's check a couple of things. Sorry. 999. Okay. I'm just wondering that did I copy paste this list wrong? Yeah, I think I did. I have a feeling now. That I somehow miscopied it. But it's fine. It's fine. Although it makes or means that yep. Although I'm not sure that I can't recall the original value now or the previous value. Oh, there it is. Yeah, it actually was higher. Interesting. Yes. Nice. Then, part 2. Your analysis only confirmed that everyone feared the two lists of location IDs indeed very different. Or are they? This one can be agreed which group made the mistakes or how to read most of Chief's handwriting within, but in the command. Maybe the other numbers aren't location IDs, but all rather misinterpreted handwriting. Okay. This time you'll need to figure out exactly how often each number from the left list appears on the right list. Calculate total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Aha, okay. Yes. Okay, so if we add text day 1 part 1, okay, then we can say here day 2 part 2, and then we can use the same inputs. Yes. Yes, both these are actually the same. Sorting doesn't really matter. So we need to calculate how often each number from the left list appears in the right list. Okay. So Yeah, what we need, we need some kind of variable to store how many times the calculate total similarity score by adding up each number in the left list after multiplying it, okay, times the number appears. And then, okay, so basically if we have like 3, let's actually go through these. So if basically it's not even once there, then it's 0. Okay. So basically we could do left numbers, and we could, I think dictionary would be for number in left list. Yeah, so let's loop those through, and then we will loop let's make it like this, and then for right, so we need to for right, actually is there in right list, and now we just kinda check if left number equals right number, we will add it in. So basically if not left numbers number, so we should first check that is it there, and then if it's not, we can just set it to be 1. Oops. We can set it to be 1, and then else we can just do this, I think. Syntactical error. Okay. Oh yeah, because it's, yeah. Actually we could then convert this to be get instead. So then it will return none. Yes, and then if we check the left numbers, yes, this is how many times it's actually not that many of those numbers did actually. So now we have the numbers. So we should then calculate that how many times. So we need results, which is an empty array. Number key in left number dot keys. Oh yeah. Yes. Results. Let's append the key times left numbers. Yes. And now if we run this. Yes. Oh. Why it jumped there? I'm not sure. And then we can check the results. Yes, and then we wanted to sum them up. Yes. Yes. Nice. So that was the first day. So day 2, part 1 is the next one. So we can go return to the take the day 2. Red-nosed reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. No sign of the historian and the engineers. They run up to as soon as they see you. Apparently they still talk about the time Rulov was saved through molecular synthesis from a single electron there. Will it add that since you are already here, they would really upset you analyzing some unusual data from red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. Okay. The unusual data, your puzzle input, consists of many reports. The report per line, okay. Each report is a list of numbers called levels that are separated by space. Yeah. Okay. So what we want to do okay, get your puzzle input. We can okay, and I think modify my helper a bit. Yes, so basically what we want to do here, how we want to change this is to for part in parts we are not actually, for this time I don't want to have tuple. I think it's easier if we will just temp values temp parts and then parts. I can't type for some reason today. Temp parts, and then let's append the part after casting it to integer, and then tuple array dot append. Actually, we can append them parts like this. I think it should be fine. Yes. Yes, surely. Yes. Actually, let's fine-tune the input a bit so that there won't be the last line. Just eases up the process a bit. Now we have new input. Yes. Cool. Then what we need to do, 6 reports containing 5 levels, okay. Which reports are safe? No safety systems can only tolerate levels that are either gradually increasing or gradually decreasing, so on. Count as safe if both of the following are true. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least 1 and at most 3. Okay, safe because levels are decreasing by 1 or 2. Okay, yes, unsafe because... Yeah, okay. Aha. This is report safe. Then report comes in. Report is an array or list. Prev previous number is report the first number from the report. So for then number for number in report now we should then be able to check the difference. So if prev number if ups, yes, prev minus number is created or is okay, at least 1. So this is more 1 and 3. Then we can just say return false. Wait a moment. So if then if that is the case, then we can continue. Yes. Else return false. Return true. So we look through all the values. We need to set the to be the number. Maybe this actually could be better than current. Yes. And then, so in this, how many reports are safe? Okay. So let's just run that, and then amount of safe reports. Let's start by 0 for input in inputs. Is safe. That's it. Maybe if is report safe input. Yeah, and then amount of safe reports plus equals 1 amount of safe reports. I think this should be enough. 597. Too high. Okay. Oh yeah. And they should be kind of, every number should go kind of the same direction. Oh. Okay. Prev direction. Or like going up. None. So with the difference is like that, okay? Maybe then another if check. If going up, we can if going up, previous current yes, and then we need to check that is going up is equals to, so basically previous minus current is above 0. So if it is above 0, then we know that it's going like this. We know it's going up because its current number should be bigger. And then elif going so basically we want to check that if going up is this, so it should be still going up. Then we just do this and then else return false. Yeah. 300. Okay. So the difference can be on like this, and then if yeah. If going up is none. Yeah. Huh. Okay, that does not look. Because we can surely okay, so if going is none, then we set it up. Okay. Oops. Can we close or minimize this somehow? I'm wondering about this. Is it like always going to say false? Yeah. Oh god. Jumpy. So this is somehow wrong. Is it like then this that we need to have there some additional curly brackets? Yeah. Stupid thing. Which I missed. $572. Yes. Continue the part 2. Yes, so day 2. Part 2. So, the engineers are surprised by the low number of safe responses until they realize that they forgot to tell about the problem dampener. Okay, the problem dampener is reactor mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. Aha, okay. Now the same rule applies before. Expect it removing single level from an unsafe report would make it safe. The report instead counts as a safe. Aha, okay. So we instead of immediate return has tolerated value false. Else if has tolerated value, then return false. Else has tolerated value, true, and then continue. Although continue is a bit. I think this should be actually all we need. $581. Oh. Oh. Yes. Yeah, like this. Oops. $5.99. Oh. Was a bit too fast. I like a lot the Colab. It's so kind of agile to play with the numbers and stuff. Okay, we didn't yet get the interesting. Okay. Actually, I'm not sure what this is. Okay, yeah. If has tolerated value, if that is true. So if there is some. Oh, yeah. Of course. We need to do this. Yeah. Of course. Now I think we are close. No! So if it is something like this, let's check. Yeah, okay. Too low. So if the Aha. Aha, yeah. Now I understand the problem. So if the second, based on the second number, it is going up, but that is the problematic number. Yeah. Okay. So if the second number in the report is going to the another direction and happens to be bigger, or does not actually need to be the bigger one, but if it goes to the different okay, this makes it a bit more complex. So I should let's write it here to do. Yes. Yeah, so what we need to do is to basically check if there is only one faulty value in that. Okay, so okay. Maybe we could get index. We could zip enumerate. Yes. So basically, if the index is, let's actually check that what are the index. In this case, they should be like not enough values to unpack. Express 2 got 1. Let's see. Yes, so we have the it's actually vice versa. Yeah, always goes wrong side. So yeah, we can see that it's 0. Okay, as it should. So if the has tolerant value is true, or we set it true, so basically we are going the numbers through. The first, or like the second in the overall report is the off number. So basically, example here. So if we go here, then we should put the this is actually interesting because we should kind of jump jump over. So if we here check that was the yeah, okay, let's check if index is 1, and not. Yes, so then we can update this. But not with preview. It's the report 1 and then current. Yeah. Yeah, we need to move this to here. So if the index is 1, and I think it could be something like this. But this can happen only once, as it does. $607. What was the previews? I can't recall. Was it $5.99? Okay. Yeah, I need to think it a bit more. Yeah, maybe that kind of the reason also of the toleration. So it's kind of wrong. Going to the wrong direction, is it like yeah. But I think this has gotten already a bit longer this video, so let's pause it here and have a break and continue a bit later. Very happy if this video was any or even closely interesting. But yeah, thank you for following, and see you next time. See ya.